Hello students and welcome to our class today. Today I want us to look at the surface area of a pyramid. Surface area of a pyramid. So far we have known what a pyramid is, and now when we talk about the surface area, which is actually the area of all the surfaces that particular pyramid is going to have. How do we get that particular surface area? That is actually our interest in this particular discussion. So for the surface area, if you have a pyramid, you have your pyramid, which is like that. When you are told to get the surface area, you simply supposed to get all the surfaces or the areas of all these surfaces, then you add them to get the total surface area. Remember, we are going to have the slant faces, which are actually triangular, which are four of them. This triangle that we have here, this triangle that we have here, the triangle that is on the other side, the triangle that is on this side. If we get the areas of those particular triangles and then we add all the areas, then we are going to get the surface area of all the slant faces, and we also get the area of the base, which is going to be either a square or a rectangle. And if we now sum the area of the base plus the area of all the slant faces, we get actually the total surface area. We shall get the total surface area. So let us look a case whereby we have got this as a square, where you are told that this is 10 centimeters by 10 centimeters, and you have been told that this slant height is actually 12 centimeters, like that. So one thing you should be able to note that if the base is a square, all these slant edges are going to be the same. So if I can be able to bisect this one for your view, so it is like having this is 10 and this is actually 10. Remember, these particular faces that are slanting, which are actually triangular in shape, are going to behave like this. It is like you have got something like that. If you bisect it and open it, if you bisect all the slant edges, if you cut this and you cut that, you cut this edge and you cut, and then we open it, it's going to be a resemblance of what I'm having here. So that if we raise this part, we raise this part, we raise this part, we raise this part, they all meet at the same point, like that. So one thing you should be able to know, if you are told that the base is 10 by 10 and all these slant edges are 12, 12, 12, 12, 12, like that, you can be able to get the surface area of this by getting the area of one triangle. If, for example, I have one triangle like that, this is 10, this is 12, and this is 12. Am I not able to get the area of this particular triangle? So I can come here and I bisect this one so that it becomes 5 by 5. I divide this 10 by 5 by 5, so that actually I'm going to have a right angled triangle here, and then I have this is 5, this is 12. Am I not able to get this height through Pythagoras theorem? That height is going to be the square root of 12 squared minus 5 squared, which is the same as 144 minus 25. We take the square root. So 144 minus 25 is equals to that. Then the root of 119 is 10.9. So this height is 10.9. If this height is 10.9, which is the same as the height here, which is the same as the height here, which is the same as the height here, all through, now you can be able to get the area of that particular triangle, and the area is a half times the base, which is 10, times the height, which is 10.9. So this is the same as 5. If we multiply by 5, you get it is going to be 54.54. Then you multiply by 4 because we have got 4 triangles. You get it is going to be 218.17, and to this 218.17 you add the area of the base, which is 10 by 10, which is 100, which is going to be 318.17, like that. And then you are able to get the total surface area. So the total surface area of a pyramid, it is the area of the base. In this case it is 10 by 10, giving us 100, plus the area of all the triangles. So if it is a square, all the triangles are going to be the same. So you simply get the area of one triangle as we did here, then you multiply by 4 to get the total area of all the 4 triangles, plus the area of the base will give you the total surface area for that particular pyramid. If it was a rectangular base pyramid, as sometimes you can be able to encounter in some questions, let me have it like that. If it is actually a rectangular, if it is a rectangular base pyramid, let me have it well drawn. If we have it like that, again, it is not coming out very well. If we have it like that, remember this one can be bisected such that you have your triangle, your rectangle, sorry, like that. Let us say this is a 12 by maybe 7. So this side is 7, this is 12, like that. So if you bisect it and have it like that, if you have it like that, you should be able to realize that all these triangles are not going to be the same. Let us say this height was 15. So we are going to have 15 here, 15 here, 15 here, 15 here. All these are 15. But you should be able to realize that this triangle and this triangle, let us call it triangle A and B, are going to be the same, and C and D are also going to be the same. So we have got two similar triangles which are opposite each other. So what you need to do is to calculate the area of one triangle. Like for example, you calculate the area of C, you multiply by 2 because it is the same as area of triangle D. You also calculate the area of triangle A and multiply by 2 because it is actually the same as the area of triangle B. And then you calculate the area of the base, and then now you add the area of these two triangles plus the area of these two triangles plus the area of the base to get the total surface area. Thank you very much.